Hey, it's Mr. Allred, and we're going to talk about ratios and equivalent ratios. And you'll see a lot of similarities between ratios that we're talking about now and rates that we have previously talked about. So, first of all, a ratio is a comparison of two quantities with the same type of unit. So, if you think back to rates, we wrote them like miles per gallon, and miles is a distance and gallons is a volume or a quantity. But there's no like real connection with those units by themselves. Here there'll be some way to view these units as the same thing. But first of all, we also want to touch on the notation, which we're going to do in the example, but a ratio can be written as a fraction or using a colon. So let me see if I can make that clear with the example. There are 50 dogs and 30 cats at the Humane Society. Write the ratio of dogs to cats. So first of all, thinking about what we have here, they're the same type of units because even though they're dogs and cats and that's different, they're both animals, so we can kind of see the relationship of how we would compare them. So we wouldn't really want to divide dogs by cats in general to find something like a unit rate, but we like to know like how they compare to each other. And it's very important over here that it says dogs to cats. So that's going to be our understanding. So we can write this a couple of ways. One would be as a fraction, so we might say 50 over 30, but it might be good to go ahead and write out what they are. Even though they're both animals, it might be good to be a little bit more descriptive. So 30 dogs over 30 cats. And honestly, it's a good practice to write these things if you have a fraction in reduced form. So 50 over 30 could reduce to 5 over 3. So we could write 5 dogs to 3 cats, and that's the way we should think of it. That's the fractional notation. So using a colon, it could look something like, sometimes you will put the explanation with it, 5 dogs, colon, the grammatical colon, to 3 cats. Or sometimes you might just see it if you have the understanding of what you're writing, 5 to 3. But units are never a bad thing to put with a problem. Okay, so we can write as a fraction or with the colon, and we'll try and use both as we go along. Okay, the second example here, we're still going to be writing it, but I've included it because it's a little bit different. It says, Austin buys a bag of candy for Halloween that contains Starburst and Skittles. The bag says it contains 180 pieces. Austin counts 60 Starburst. What is the ratio of Starburst to Skittles in the bag? So if we're going to write this thing as a fraction, we need Starburst on top and Skittles on the bottom. So it tells us there's 60 Starburst, but if you read carefully, and that's the key here, it seems very simple to compare two things, but read very carefully. It says the bag contains 180 pieces and 60 are Starburst. So it never explicitly says how many Skittles there are. But if you subtract those, you have 180 pieces, 60 of them are Starburst. If you subtract them, that leaves you with 120 that has to be Skittles. And I think if we reduce that, we'd have 1 Starburst to every 2 Skittles. And we could write that 1 to 2 if we want to use the colon notation. But it's not just as simple as looking at the two numbers that might be given sometimes, because we want you to think about what's being asked. Okay? And also, I could have asked what is the ratio of Skittles to Starburst. And if you did that, this fraction would be upside down, so it would be 2 to 1. So also pay very close attention to the order things are given, because that's the way you're going to be able to read what you're supposed to do. So next we're going to do equivalent ratios. So two ratios can be compared similar to comparing rates as a proportion. Now generally, excuse me, we'll do this in the colon notation. We won't do it in fractions usually. It says instead of using the equal sign, the ratios are separated by a double colon. So very quickly, an example could be like we just had. We had 60 to 120. Okay. So 60 Starburst to 120 Skittles, that's equivalent, double colon, to 1 Starburst per every 2 Skittles. Okay. So that's pretty much, when you view it as a proportion, the same thing as saying 60 over 120 equals 1 over 2. But this is ratio notation. Okay. So let's see here. What we want to do next is we want to take this thing and we want to see a problem with equivalent ratio where we have to solve it. So we might see something that looks like 7 is to 3, which is equivalent to some unknown equivalent to 24. Now, while this is the way we write it, we can think of it kind of like the proportional notation. Okay, and if that helps, I don't blame you. So proportional notation would be like 7 over 3 is equal to something over 24. So we're trying to figure out what's missing here. So if we cross multiply, I need to pick up a calculator, but cross multiply, 3x equals 7 times 24, 168. If we divide both sides by 3, x will be 56. Okay. So basically 7 is to 3 as 56 is to 24. So it's an equivalent ratio. Okay. Let's see a couple of places we could use that to solve some problems, and we will use it very much similar to we have to having used proportions in the past. Example, there are 2,000 college graduates in a certain county. The ratio of college graduates to those without college degrees is approximately 4 to 7. Okay, so we're given a ratio here. How many people in the county do not have a college degree? Okay, so we're kind of given a complete ratio here, 4 to 7. So this is, the 4 is with college degrees, the 7 is without. So we're going to compare that to college degrees. We know there are 2,000 as it says, but we don't know how many don't have a college degree. So we could write this as fractions individually, but generally you'll see this notation for ratios. So just thinking about it, I find it's very much easier to think about it as a proportion. So 4x equals 14,000. And if we divide both sides by 4, I kind of know that, but let me use a calculator. I get the x is 3,500. So let me kind of take this in two directions. We could say that, excuse me, 3,500 do not have a college degree. But now that we know how many have a college degree and how many do not, we could also use that idea of the ratio to tell how many people are in the county. So we could have like a side note here, because it's not what the question is asking, but I do want you to realize you could figure it out. There are 5,500 people in the county. So if 2,000 people 2,000 people have a college degree and 3,500 do not, that takes us to add them together and get to 5,500. Here's one more problem we could do. It is estimated that domestic cars outnumber foreign cars by about 7 to 5. If there are 4,152 vehicles in the county, how many of them are domestic? Now, that's a good question. So you got to think about what we have here. So that's why I kind of leaned on the side note before, but there's 4,152 total. And if we think about what we have here, we have a 7 to 5. Okay, so we're comparing there's 7 domestics to 5 foreign. Well, if that's true in the simplest terms, we're talking about 12 total. So what we could do is we could divide this, okay, by 12. And when we do that, what we see is there's 346. That's what is 1/12. Is 1/12 of total cars. So take a moment to process this, and if you need to stop it or rewatch it, just kind of note where we are. But when we say something along this lines, it says how many of them are domestic. So basically when we look at this, we could look at a couple different things. We could say that we have 7 to 5, 7 domestic to 5 foreign, or we could say we have 7 domestic to 12 total. And that would be the 7 plus the 5. So as you can see, these 12, each one of them is about 346. But what we're asked is how many cars are domestic. So we may have gone on a wild goose chase there. But we have 4,152 total. So we're looking for how many domestic. So I could take the 342, since I've already found out that's 1/12, and multiply it by the 7. So that might make sense. But let's also do it with the proportion. So I'm going to cross multiply. Got a big number here. 7 times 4,152 is 29,064. So if I divide both of those by 12, let's see what I get here. Divided by 12, I get 2422, which is the number of domestic cars we'd be expecting. Let's see off here to the side, if we took that 7 times the 346, if that gives us the same thing. So 7 times 346 gives us the same thing. So there's 2 ways to kind of answer that question. Kind of using a ratio and kind of using a fractional notation as well. You'll see some problems like that, so take your time with them and maybe ask some questions if you get stuck.